All right, so what we have here is a slightly different vector decomposition problem. Again, I'm trying to write this vector f in terms of e hat 1 and e hat 2 directions. But what makes this different is that I have two angles here. One that represents the orientation of vector f, and another one, phi, which represents the orientation of my basis vectors e hat 1 and e hat 2. But the principle of doing the decomposition is pretty much the same. I've got this vector f right there. That's that one right there, and I want to write it in terms of vectors in the e hat 1 and e hat 2 direction. So I create this triangle where the other two sides are along the e hat 2 and e hat 1 direction. In fact, let me just do it right now. So I'm going to start at the base or the tail of f. I'm going to go in the positive e hat 2 direction this much, and I'm going to go positive e hat 1 direction that much, so that when I lay these vectors out, these pink vectors out tip to tail, they sum up to the vector f, right? So now what I have to do, just like before, is I try to identify an angle, and here really I have two angles. And what I do is I notice that, it's this angle right here that appears, maybe I'll do it in blue, it's this angle right here that appears in my vector triangle, right there, right? Right? It's this angle between the e hat 2 direction, there's the e hat 2 direction, and the direction of f, which is that way. So this angle right there coincides with this angle right there. And you'll notice if I take this vector f and sort of extend it through, and take this horizontal and extend it through, that this angle theta right here is equal to that angle right there. So this total angle that I'm after, this one down here, is just phi plus theta, or theta plus phi. I think I wrote it down here. So theta plus phi is that angle right there in my forced triangle, and now it's just my standard type of problem. So in the e hat 1 direction, I've got a sine of that angle, theta plus phi, because in the e hat 1 direction, this is the e hat 1 direction. It's on the opposite side of this angle right there, so that's why I get a sine theta plus phi. And notice that the e hat 1 direction, or the e hat 1 component of my vector, is aligned with the e hat 1 direction, so there's no minus sign there. Then in the e hat 2 direction, I've got a cosine, because here's the e hat 2 direction, it's the adjacent side in the triangle. So cosine, and then also it's the e hat 2 component is sort of aligned with the e hat 2 direction, so I get a plus sign right there. So there's my answer. I think I'm happy with this. So let's call it done.